Okay. So now what I'm going to do is to put together hydrogen with nitrogen. Okay? Hydrogen with nitrogen. Hydrogen, we know, has only one dot, right? Only one electron at its valence level. Nitrogen, on the other hand, has 1, 2, 3, 4, 5 electrons in its valence level. One on each of the four sides, and then I can pair up. And then in order to get nitrogen up to 8 valence electrons, I want to get from someplace 3 more electrons. So I can share this electron, but that's not going to satisfy nitrogen's need to have a full valence level. So I'm going to put another hydrogen here and share those two, and that gets nitrogen up to 7, and one more hydrogen, and I can get to 8 valence electrons for nitrogen. Now, that gives me then, we started with electron dot formulas. We circle electrons to make a sharing arrangement. Now we want a Lewis dot formula. For a Lewis dot formula, we're going to put the pairs of electrons, these are called unpaired or unshared pairs up here. Then we're going to put the shared pairs in between the symbols for the two elements. So those two electrons got squeezed in here like this. These two electrons from here get squeezed in here. These two electrons from between nitrogen and hydrogen get squeezed in down here. And that's a Lewis dot formula. Okay?
Does this go in a lambda book
well, that's kind of up to you. This is more notes, but if you want to put it all in one place, you can put it in the lab notebook. Okay? We're trying to get to the three-dimensional shape. Yes. All right. Now, so how many long balloons do I need now? 3 of them. Each time I have a shared set here, I need a long balloon. And a sigma bond is going to be directly on a line between the two nuclei of the two atoms. So between nitrogen and this hydrogen, I'm going to have a sigma bond. And you made this little thing down here for the hydrogen, right? Between this nitrogen, the same nitrogen, and this hydrogen, I need another sigma bond. And I'm going to have this one kind of swinging out toward you a bit. Okay? And then between the nitrogen and this hydrogen, we're going to tuck this one kind of in behind here. Okay? And then we're going to have a lone pair of electrons. And a lone pair of electrons has a more of a balloon shape like this. Okay? And that's what a balloon model for ammonia would look like. The name of this molecule, NH3, is ammonia. Okay, if I were you, I would do the best I could to try and remember that now, because eventually you have to memorize that name for that formula. Ammonia. Yes? I'll be back in a second. Okay? Now, this is an sp3 hybrid right here. All of these single bonds come from sp3 hybrids for this molecule. And all of the single bonds are sigma bonds. Okay? You got that? Now all of these come from sp3 hybrid orbitals. That first model we did yesterday, we started with an sp3 hybrid. They all come out of that. Or the way you think about it is you start with 4 round balloons, okay? And then when you share an orbital, one of the balloons represent an orbital, you elongate it into a long balloon, okay? And that gives you a reasonable facsimile of what a how the bonds will actually look in space. Okay, if we were actually able to see bonds or sharing of electrons or lone pairs, they would take up that space. Now we can't see that. We mathematically predict that behavior. Okay. All right. So just for time, I felt like I needed to move on now to double bonding.